In this video, our topic of discussion is applications of potentiometer. In the previous two videos, we have seen what is the necessity of a potentiometer, then we saw the principle of a potentiometer. Now we are going to concentrate on its application. It has two main applications, in which the first one is to compare EMF of two cells and the second is to calculate the internal resistance of the cell. So in this video, we will concentrate only on comparing the EMF of two cells. Okay. So for that, what we need is a potentiometer wire. So you have a potentiometer wire AB, as I mentioned in the previous video. If you take a wire AB of length capital L, you bend it in this form and keep it. Then this particular device is going to be the potentiometer, right? Now the terminal A is connected to a cell of EMF E, okay, and the name of this cell is called as the driver cell. Then, like how we saw in the principle, the driver cell is going to have the internal resistance R and it is connected across an optional resistance box along with a key to control. Now the question is, we told to compare the EMF of two cells. What are the two cells that we are going to use? So the two cells that we are going to use are E1 and E2. We need to compare their EMFs. So what exactly are we going to do is, we are going to use the principle of potentiometer in this experiment to make this comparative study. For that, let's try to understand the circuit diagram. So till here, if you observe, this is the basic potentiometer. So across this basic potentiometer, what we are going to do is, to the terminal A, the positive terminals of both the cells for which the EMFs are to be compared is connected. Then the negative terminal of both the cells are connected to a galvanometer and a jockey in subsequence. Okay. So this is what is going to happen, and there are two keys K1 and K2 which are used to control the open and closed circuit condition for the cells E1 and E2. So what they will do is, they will try to bring one cell at a time into the whole circuit. So remember, certain points to be concluded are, we have a driver cell and we have two cells of EMF E1 and E2. The two cells to be brought into the circuit are controlled by using key K1 and K2 respectively, but this driver cell is going to be the one which is going to exist in the circuit throughout the experimental process. Okay. Now what will happen is, once you make all these connections, we are going to close the key 1. So when you close key 1, what is going to happen is, the cell with EMF E1 is going to come into picture of this whole circuit. So when that is going to happen, we need to start moving this jockey. So when you experimentally do this, you need to start moving the jockey in this way. I am using a red color, observe. So you need to move the jockey in such a way that you keep going, and you will stop at a point exactly where the galvanometer shows 0 deflection. And when this happens, the circuit is said to be under open condition, and the point where the galvanometer shows null deflection is what is called as null point. Okay. At this instant, what is going to happen is, the principle of potentiometer comes into picture. As we know, the potential difference across the point A and C1 is directly proportional to the distance between the points A and C1. Let's say that length is L1. And one more important point is, during the null point condition, the circuit is going to become open. And we know that when there is an open condition that is going to happen, then the potential difference is equal to EMF. That is what we saw in the first video. When we saw the necessity of a potentiometer, we discussed it, right? So from this point, can I conclude saying that when VAC1 is directly proportional to L1, it also implies the EMF of the cell 1 is also directly proportional to L1. Right. So this is what we did with respect to cell 1. So let us have this information, or I can write it as E1 is equal to K times L1. Have this point in your mind. Now what we are going to do is, key 1 is opened and key 2 is closed. So when this is going to happen, the cell number 2 is going to come into picture. Again, you start moving the jockey starting at point A. You keep moving in such a way that you stop at a particular point where the galvanometer again shows a zero deflection. Let's say at this time, the point where the null deflection is happening is C2. Then we can conclude that VA C2 is directly proportional to L2. The similar condition is going to happen. It is again going to be open condition. From this we can conclude that E2 is directly proportional to L2, or E2 is equal to K times L2. So observe, we have two data in our hand. That is, E1 is equal to K times L1 and E2 is equal to K times L2. Then when we divide both the expression, we get E1 by E2 is equal to K times L1 divided by K times L2. K and K will get cancelled. From this we can conclude that E1 by E2 is equal to L1 by L2. Means we are trying to compare the EMF of two unknown cells by using the principle of potentiometer, since it is easy for us to calculate the distances. So EMFs are compared in proportion with the lengths, the balancing lengths that we get as the output by moving the jockey. So this is all about the comparison of EMF of two unknown cells.